Hi there, in the last video I went through the chain rule, but I also went through this result which was found using the chain rule. So let me go through this result. So remember, if y equals a into ux to the power of n, a, remember, and n, these are constants, and ux is a function of x. So in particular, if a is a constant, dy over dx is this result here, and remember the result is saying multiply by the power, so n times a gives you this na. Then you subtract 1 from the power, so if you subtract 1 from n, you get n minus 1, but you need to multiply by the derivative of u, and u is the term here, okay? Now, I did stress in the last video that we only apply this result if a is a constant. But the question is, what happens if a is not a constant? If a is not a constant, we're going to apply the product or quotient rules, okay? So if a is not a constant, it's going to be either the product or the quotient rule. So that is what this video is about. So let me title this Product and Quotient Rules. So let me take a red pen, underline this. So first of all, let me go through the product rule of differentiation. So the product rule states that if you have a function of the form y is equal to ux vx, okay? So ux and vx are functions of x. So where ux and vx are functions of x, okay? So dy by dx, so if you want to calculate dy over dx, the rule is v du by dx plus u dv over dx. So that is the product rule of differentiation. Sometimes instead of du over dx and dv over dx, you can use the primed notation. So instead of du over dx, you can write that as u primed. So u primed is the same as du over dx. And likewise, instead of dv over dx, you can use v primed. So v primed is the same as writing dv over dx. Okay? So you could write this as vu primed plus uv primed. However, I like to write the rule out in full. Okay? So I like to write it as v du over dx plus u dv over dx. So that is the product rule of differentiation. Let me write down the quotient rule underneath. So here's the quotient rule. So in this case, if you have a function of the form y is equal to ux over vx, so if you have a quotient of functions, ux over vx, and ux and vx are functions of x, okay? So here is the quotient rule. Dy over dx is v du by dx minus u dv over dx divided by v squared. So let me highlight the quotient rule of differentiation as well. So let's take this forward with a number of examples. So just to go back quickly, we can only apply this chain rule related result if a, the term in front of your function, is a constant. And remember, if a is not a constant, we're going to be using either of these rules. So if it's a product of two functions, we're going to use the product rule. And if it's a quotient of two functions, we're going to use the quotient rule. Okay? So So let's take it forward with this example. So example number 1. So question is defined dy by dx. And here's part A. Let's differentiate y is equal to 2x into the root of x plus 1. So y is equal to 2x into the root of x plus 1. So let's look at this function carefully. So the term in front is 2x, so 2x is like our a, okay? So a is not a constant, so that means that we need to use the product rule here, since we have a product of two functions. So in this case, I'm going to take my u to be 2x in the product rule, and I'm going to take my v to be the remaining function, which is the root of x plus 1. So let me first write down in step number 1 the product rule. So by product rule. So remember the rule, dy by dx, that's v du by dx plus u dv over dx. And in step number 2, I'm going to introduce a side calculation, and I'm going to calculate du over dx as well as dv over dx, okay, using u and v. So first things first, u is 2x, so in this case du by dx, so when we differentiate 2x, we're simply going to get 2. Let me introduce another side calculation alongside this one. V is the root of x plus 1. So the root of x plus 1 is the same as writing x plus 1 to the power of half. Okay. Now, let's think about this one. The term in front of x plus 1, so our a term is 1. 1 is a constant, so that means that I can apply this chain rule related result as we've seen in the previous video. Okay? So remember the results. We need to multiply by the power to give us the NaUX. Then we subtract 1 from the power, giving us n minus 1. Then we need to multiply by d by dx of u. Okay, so u is the term here. So if you're unfamiliar with this rule, be sure to watch the previous video that I did on the chain rule. Okay, so let's apply that rule over here. So the power is half, so I'm going to multiply by the power. So dv over dx is going to be half times 1 is half into the x plus 1. Then we take away 1 from the power, so it's going to be half minus 1. And then we multiply by d by dx, and our ux is x plus 1. Okay? So if I simplify this, d by dx of x plus 1 is simply 1. So dv over dx therefore will be half times 1 is half into the x plus 1, and half minus 1 is minus half, and you could just as well rewrite that as 1 over the 2 from here into the root x plus 1. So x plus 1 to the minus half, remember, is the same as 1 over root of x plus 1. So that is step number 2, our side calculations, and here is step number 3. So step number 3, the final step, let me replace this data in our product rule. So dy over dx, that's equal to v. So rv is the root of x plus 1 times du over dx, so du over dx being 2, plus, and our u is 2x, multiplied by dv over dx, and here's dv over dx, it's 1 over 2 into the root of x plus 1. Okay, so let's expand. So this 2 and this 2 will cancel. So dy by dx, when we simplify, will be 2 times the root of x plus 1. Let me leave that as 2 into the root x plus 1, plus x times 1 is x over the root of x plus 1. So that's going to be the solution to the first part A. Okay. So just to go back quickly, we applied the product rule purely because the term in front of our function is a function of x. So RA, in other words, is a function of x, it's 2x. And since we have a product of two functions, that is the very reason why we applied the product rule. Okay. Let's take a fresh page. Here's the part B. So in part B, let's try and differentiate. Okay, y is equal to 2x squared into 2x plus 1 cubed. So let's have a look at this function also. So let's have a look at it carefully. So the term in front, so our a term, the term in front is 2x squared. So our a is not a constant, it's a function of x. Since we have a product of two functions, we're going to apply the product rule. So u, I'll take that as 2x squared. V, the remaining term, which is 2x plus 1 to the power 3. So let's quickly remind ourselves of the steps. Step 1, let's apply this product rule. So in this case, here's step number 1. So by product rule, so remember the rule, dy over dx, that's equal to v du by dx plus u dv over dx. Okay. Now in step number 2, remember in the previous example I did some side calculations for du over dx and dv over dx. So I'm going to do the same here. So let me do a side calculation. So u is 2x squared. So du over dx, when I differentiate 2x squared, I'll get 4x. Let me present another side calculation. So v is 2x plus 1 to the power 3. And let's think about dv over dx. So once again, if we look at this function carefully, the term in front, so our a term is 1. 1 is a constant, so that means that we can apply this chain rule related result that we've seen in the previous video. Okay, so let's apply that result again. So remember the idea. First we multiply by the power. So 3 times 1 in front is 3 into the 2x plus 1. Then we take away 1 from the power. So 3 minus 1. And then we multiply by d by dx of the term u, so our ux or u is 2x plus 1. Okay? So if I simplify this term outside, d by dx of 2x plus 1 is simply 2. So further to that, dv over dx, if we simplify further, 3 times the 2 is 6 into 2x plus 1, and 3 minus 1 is 2. Okay? So now that we completed the side calculations in step 2, let's go to the final step, step 3. And remember, in the last example, it's just a replacement of the data that we had in our side calculation into our product rule. Okay, so let's replace all of the data that we have. So if we replace the data, this is what we're going to have here. Okay, and I can simplify this. So if we factorize, so if we look carefully and factorize this, so as far as the numbers or the constants are concerned, I have 4 here, and I have 6 times 2, which is a 12. So as far as the numbers is concerned, I'm going to take out a common factor of 4. Okay. Also, I have a 2x plus 1 cubed and a 2x plus 1 squared here. Let me take out a factor of 2x plus 1 squared also. Okay, so this is the common factor that I have, but in addition to that, I have x from here and x squared from here. So let me include an x here also. Yeah, so I'm going to take out a common factor overall of 4x into 2x plus 1 squared. So 4x into 2x plus 1 squared. So by doing that, be careful what we have remaining. So I have a 2x plus 1 remaining. So since this is cubed and I'm taking out a squared, I have a 2x plus 1 remaining. Plus, I've taken out a constant of 4. However, I have 6 times 2, which is 12. So I have 3 remaining. And since I've also taken out an x common factor, since I have x squared from here, I have a 3x and 2x plus 1 squared. However, I've taken a 2x plus 1 squared as a common factor. So this is what's remaining as far as this bracket is concerned. So if I simplify further, dy by dx will be 4x into the 2x plus 1 squared. And if I simplify this term within the square brackets, 2x plus 3x is 5x plus the 1. And that should be the solution to this very problem, part B. Okay? So here are the steps involved with part B. Okay? I've did 2 parts concerning the product rule. Okay? Let me do a quotient rule related problem also. Okay, so let me do just one more example, one more part. So here's a part C. Let's differentiate y is equal to, in this case, 2x plus 5 over, okay, x minus 1 squared. So 2x plus 5 over x minus 1 squared. So in this case, we have a quotient of 2 functions. We need to apply the quotient rule, okay? Or what you could do is you can take the x minus 1 squared up and apply the product rule. So you can do this problem in either way. I'm going to use the quotient rule just to show you how the quotient rule is applied. So I'm going to take u to be 2x plus 5. So u is the numerator and v, that term being the denominator. So when you apply the quotient rule, u is the term in the numerator, v is the term in the denominator. Okay? So in step number 1, by quotient rule, so let me write down the rule, dy over dx, that is v du by dx minus u dv over dx, everything over v squared. Okay, so that is our quotient rule. Now, just as I've done with the product rule, I'm going to do 2 side calculations for du over dx and dv over dx. Okay, so just as I've done earlier with the product rule, let me start off by writing a side calculation for du over dx. So u is the term in the numerator, 2x plus 5. Let's work out du over dx. So when I differentiate 2x plus 5, it's 2. Let me do another side calculation alongside this one. V is the term in the denominator, x minus 1 squared. And let's think about dv over dx. Okay? So the term in front of this function, our a term, is 1. 1 is a constant, so we can go back to the chain rule related result that we've seen in the previous video. Okay, this rule over here. So let's apply that result. So remember, first multiply by the power. So 2 times 1 in front is 2 into x minus 1. Then we subtract 1 from this power, so it's 2 minus 1. And then you multiply by d by dx of u. U is x minus 1. Okay? Let's simplify this further. D by dx of x minus 1 is simply 1. So if we simplify, dv over dx will be 2 times the 1 is 2 into x minus 1, and 2 minus 1 is 1. Okay? So the side calculations are complete for dv over dx as well as du over dx. Let's go to the final step, step 3. So in step 3, let me replace this data in our quotient rule. So dy over dx, that is v, so v in this case is x minus 1 squared, multiplied by du over dx, that is 2, minus, so a minus, u, which is 2x plus 5, times dv over dx, and that being, so let me use a square bracket here, 2 into x minus 1, divided by v squared. So all of this divided by v is x minus 1 squared, so x minus 1 squared, with another squared, don't forget. Okay? So let's simplify this. So dy over dx is equal to, so let me factorise this, and let's be careful with the factorisation of the numerator. So as far as the constants are concerned, I've got 2 here and 2 here, so I'll take out a common factor of 2, and I've got x minus 1 squared and an x minus 1 here, so let me take out an x minus 1 term. So my overall common factor is 2 into x minus 1. Now be careful what remains. So in this bracket here, x minus 1 squared, and I've taken out a common factor of x minus 1 from here. So I've got x minus 1 in this bracket here. And I've taken out 2 into x minus 1 common factor overall. Okay, so I'm left here, as far as this term is concerned, 2x plus 5. Okay, so this is what's left over in our square bracket, divided by, and below we have x minus 1 to the power 2 raised to another power 2. That's the same as x minus 1 to the power 4. Okay, so be careful with your factorisation. And by doing this, this x minus 1 in the numerator will cancel with 1 below, leaving me with an x minus 1 cubed in the denominator. So dy by dx therefore will be 2 from here, and let's simplify this bracket. So x minus 2x is minus x, and minus 1 minus 5 is minus 6, divided by the x minus 1 cubed. And what you could also do is you can take out a negative 1 common factor to give us a minus 2 overall into x plus 6 divided by the x minus 1 cubed. Okay, so that should be the overall solution to part C. So I did part C using the quotient rule, but I can just as well do this question or this part using the product rule. So if you brought the x minus 1 to the power 2 up, so the function will become 2x plus 5 into x minus 1 to the power minus 2, and then you can apply the product rule on that, and that should give you the same result for when you simplify. Okay? So here are the steps involved with the quotient rule, and in the earlier examples I went through the steps involving the product rule, and that sadly ends the examples and the video also. So I hope you enjoyed this video. Do related practice questions. If you did enjoy the video, a like will be very much appreciated.